Yeah, hello everyone.
Hi, everyone.
So this is Matt. I'm Michael, and today we're going to talk about Dino. And so I wanted to ask Matt. So what's your story with Dino? Why you started, and how long has it been actually?
Wow. So it's a story about excitement, I guess, because at first it wasn't seen like just a joke, but we just saw Ryan on stage explaining what he regrets from Node.js and what he would do in another way if he would be able to start Node.js again right now. So he finally came up with a brand new project, and we were just okay. That seems to be really fun, and that seems to be nice. So I guess let's try it, and we'll see. But probably no one bet on it at first. The fact is, it was 3 years ago, and it's still here, and we're still using it. Sometimes in production in some environments. So yeah, I guess it's a big win right now.
Yeah, I remember like watching this talk 3 years ago, and Ryan was like, "Okay, it's really early. If you don't have experience with LLDB, you you probably want to try out this right now." Yeah, that's
Yeah, it was fun, if a fun time, but it was probably as exciting as when 10 years before you were just coming again on stage and just saying, okay, I have a new idea, I want to put JavaScript on the server, and everyone was just, what? Okay, cool, let's do that. So yeah, this is always a lot of excitement.
yeah. And I was talking with some guy on Poimandres open source collective. He was probably previously was doing some maintainership on Flex library and post processing. You don't need to know about this, but I was like asking him, "What do you do now?" And he was like, "Yeah, I'm doing Dino stuff. I don't do this right now." So yeah, on this note, I guess we can continue to the talk itself. So,
Yeah,
Matt, I'll give the phone
thank
to
you
you.
very much. So yeah, let's talk now about Dino by itself, and how does it work and how you can use it right now in production eventually if you want, but at least how to try it. But I didn't want just to cover what is Dino and what are the basics of Dino and how you could use it and how you could start with it, because Dino is already 3 years, so we can use it in a more advanced way. So because I'm a front-end guy and I work on web environment and web solutions, I wanted to see what Dino could bring us as front-end developers to help us to get more advanced solution and more advanced stuff. So this is what this talk is about. First of all, this is a story about JavaScript, because maybe at some point JavaScript finally just sucks, just because JavaScript isn't as evolved as we really wanted it to be. So sometimes we have to find some new solution to bring the best part of JavaScript on light. But this is not an angry talk. This is not about JavaScript by itself, or maybe just a little bit. The fact is, I don't blame JavaScript, because it was here when no one was here. It was just made in 10 days, making everything available to be manipulated on the browser, having anything available in the DOM, and from the DOM itself we were finally able just to manipulate everything and do everything that we want. So it was really good. It's still here, almost 30 years after that. So it was really good. But at first, it wasn't made to power application and to power advanced stuff. It was just made to just manipulate DOM and interacting programmatically with the browser by itself. So right now we want advanced stuff. And I mean, a few years ago, when we were asking, okay, do you think we could run JavaScript on the server? Everybody was, what? Running JavaScript on the server? You mean, is it really what we want to do? Because this is not really secure. This is not really powerful. Okay, it's event-driven, and that's cool. But is that really what we want to have on the server? And the fact is, yeah, we wanted to have it just because the most advanced tool we know use in the front-end environment are made with JavaScript. And we are coming from a long way, because before it was in Ruby or in Python or in C++, or whatever you want. But having the ability to develop our front-end dev tools the same way we are developing things in the browser by itself allow the developers to build their own tools on the server. And it was a big change. So yeah, 3 years ago, in 2018, Randall, the creator of Node.js, had a talk at JSConf explaining what he regrets about Node.js and what he would probably do differently if he were able to start Node.js again. So what he explained in it is that at first, in 2009, when it started the Node.js project with this idea of bringing JavaScript on the server, there were a big challenge that was the I/O challenge, because input-output events doesn't occur in the browser, but on the server, in a server environment. This is the main thing to address. So it was a big challenge to face, and it forces all the team in Node.js to work and to focus on it. But the fact is, 10 years after that, when we run now JavaScript on the server, we still want to face the I/O challenge, but this one was solved a long way before. Now we want fast, secured server, and this is not what JavaScript was made for. So he had a lot of regrets. The first one was about dynamic language versus typed language, and this is a big story of JavaScript finally, because as Ryan explained, dynamic languages are cool, and I mean really cool. You can write tests, write prototyping, some stuff, trying to have everything working, and you don't have to worry about having the proper types, having the proper signature for the functions, and so on. You can be very flexible when you want to prototype some things. But if you want to run something really fast and in a really secure way, you can't just rely on dynamic languages. You have to focus on type languages, because the type allow you to be more strength, more deterministic, and it allows you to really run the server the best way you can. So finally, what could we do to fix or trying to fix Node and JavaScript? Or more often, is Node.js and is JavaScript ready to be fixed? The answer is probably no, because there's a lot of things burned in Node.js, and there is a lot of things burned into JavaScript itself. But we can find another solution. We made TypeScript to bring typed languages and typed abilities, skills into JavaScript by itself. And we probably have the way to restart Node.js and to build it again. So about the Node.js regrets, the first one was the promise, because they were introduced at first and quickly removed from the Node.js code base, because at first it wasn't robust enough, wasn't reliable enough, and the team preferred to focus on this callback solution. But this is just a nightmare, and it is really complex to have, and we now have promise in Node.js, but it was long and it was really painful to have them. And having them as a first-class citizen in the Node.js would be probably better in the past to just have it properly functioning. Then about security, running a Node.js runtime allow it to exploit almost everything that is available to your runtime on the server by itself. So we need something more secured and more robust to prevent any leaks of permission, of data, of whatever is relevant in terms of security. The Jeep compiler, I don't know if you know Jeep, but Jeep is the way to bring the gap between the Node.js runtime and your low-level libraries like C++ or compiled libraries that are running in Node.js by itself. And Jeep allow you to allow Node.js to communicate with these low-level libraries. The problem is it needs you to compile everything from your own computer to have it able to work in Node.js, which is a way painful, a way complex, and Jeep is a nightmare to use and a nightmare to maintain. And right now, Node.js is the only project that is still using Jeep right now in production. Even the Chrome team have dropped the Jeep support to support another compiler rather than Jeep. So Jeep is really not what we wanted to have. The npm registry and the package JSON, it could be seen strange to point it, but at first we didn't have any package solution and any package management in Node.js, built in Node.js. So npm came on production and came on stage with the package JSON file to declare and to retrieve all the way the modules are gathered in your different projects. So right now, each time you are just checkouting in your project in JavaScript and you run an npm install, you could go grab a coffee and come back later, because this is just a nightmare to have everything on your local environment, downloading this shitty Node modules thing. So yeah, npm is everywhere right now with the packages on file, and this is probably not what we want to do when we are working with JavaScript right now. And all the internal black magic of Node.js. Resolving modules without the extension. Why? Because we can, okay. This famous index thing. Why index.js? Why not main.js? Why focusing on index to just having it as a default entry point in your project? Because we can, okay. As Ryan said, this is not because this is cute that you have to do it. You probably have to avoid to do it if you want to do it just because it's cute. So yeah, avoid all this black magic and having something that is more straight to understand and to work with it when you run it in production. So as I said, the main mistake was probably the lack of a modules ecosystem, because it came after. As we saw before, the main thing that we wanted to focus on when we started with Node.js was the I/O challenge. So the team didn't thought about, which kind of package management, package distribution, modules distribution do we want to have in Node.js? At this time we just wanted to have JavaScript running on the server, and that's all. So when npm came on production, having this module this module distribution available to bring a package management into the Node.js ecosystem, it was cool, but it became the de facto standard in the Node.js distribution. And because Node didn't have any solution to properly handle the package management. So it was a big mistake. And right now we need to have another solution to handle properly the modules and the way they are distributed in our environment. So the modern needs are just still focusing on the I/O challenge. This is still here and still relevant. We want a security by default and by design in our solution, something with a sandbox, a runtime, with different opt-ins to enable some permissions, but having it secured by default. And the solution to properly pass different kind of communication inside your application, avoiding some kind of event loops inside and outside your application, but having a straightforward solution to pass messages from a stack to another into your whole application. So this is exactly what Ryan had in mind when he finally get back on stage 10 years after the first talk in the JSConf saying, okay, I wanted to put JavaScript on the server. And he was, okay, I apologize for a lot of things. So it's cool to be able to have a post-mortem on a project and saying, okay, this was a big win, this was not. There are these things that I regret. But what is better is probably to come with another solution to solve those problems on production. So here's Dino. It's a new solution, new at this time. We're 3 years later than that. And this Deno solution in finally still runtime, still running on V8, that is the rendering engine and the JS engine from the Chromium project. But this is dedicated to JavaScript and TypeScript by default. So now TypeScript is a first-class citizen language into Deno, which means that you could write your code base in TypeScript and run it directly from the runtime. You don't have to transpile it to JavaScript or to convert it to another solution. You just have to run your TypeScript files from the runtime by itself directly. It's a big change because you now don't have to focus on changing your code base from one type to another, and you can unleash the real power of the typed languages directly in your runtime. So this is a big change. You still have no promises, but at the top level, which means no more callback and no more pyramid of callback of hell. All Deno async APIs always return a promise, which means that you don't have to worry about this is an async call. Could I have it replied earlier in my workflow or not? You don't have to worry about that because everything that is async still return a promise. So you just have to handle the promise in TypeScript like you do in any other project. And you have a top level async encapsulation, which means that you could write your async await calls directly in your main file, in your main function, and it will just work. So you don't have to wrap everything in an if function to async everything in your project. Dino do it for you, so you don't have to worry about it. Then Dino use modern way to distribute the modules and to distribute the packages. And it all comes from CDN, which means we don't have a package manager, don't have npm or yarn on or npm or whatever you want. We just have no package manager because Deno is a runtime, and we don't want to have any solution to handle the packages in parallel of the runtime. We don't need it, which means that we don't have any local dependencies at all. We load them from outside, from CDN, which allow us to just grab the content that we want and leave the rest outside. So all the dependencies are resolved from CDNs and are imported directly from the URL in your codebase files. We are loading only ECMAScript modules format, so no more CommonJS at all. We use the standard format because, hey, it's 6 years old right now, so we could use them even on the server and in the browser. We could load the type definition from the CDN too. So because we're working with TypeScript, we could load the types definitions directly from the CDN where the modules are located and distributed, which is really useful and really fun to do. And we have any solution to qualify the different built-in Node.js modules that we want to use in our Dino solution. We use simver to lock the different versions of the modules that we want to use, which means no more package log, no more yarn log files to version, and so on. So everything is declared right in your code base, and that's all. Which means that we don't need to have a package JSON anymore. We don't need to rely on it with a lot of noise that is embedded in this package JSON that have a lot of definitions that we don't want to use, because the package JSON was finally a duplication of what we want to use. We have the package JSON with the dependencies declared, then the dependencies required in our code bases, which was just silly. We don't have to do that, because the single source of truth is your code. So if you declare a require or an import in your code file, you don't have to have another file that also lists your dependencies at all. Your project should be able to just parse your entire code base and extract the requires that you need in your application. So bye package JSON. We don't need you anymore. So running Dino is just as easy as just writing TypeScript, importing whatever you need from the modules directly from the CDN address. So Dinoland is the official CDN for Dino, but we'll see that there is other CDNs that are compliant with Dino. And we just load the library that we want, load the module that we want with the version declared in it, and we just have to use it as if it's loaded locally in your production hardware, and it will just work as smooth as that. You just have to run it with a single line of Dino run and passing some authorization here. Because I'm running a server, I have to authorize my Dino runtime to listen on some ports, so listen to network connection, to TCP ports. So I pass the -- allow net permission to opt in my network permission for the runtime and pass it my TypeScript file, and that's all. And everything will be able to work directly out of the box. I don't have to install anything. I don't have to load anything. Just run my TypeScript file, and that's all. And this is awesome. So let's see how we could use it to advance it and to use it in a big production environment. So the first thing is Dino is a runtime, TypeScript runtime, and this is one runtime, but you could use it to run almost everything, because it's still running JavaScript on the server as Node do. So we could use it to power advanced solution like, I don't know, servers, computing algorithm problems or something like that on the server if you want. But we could also use it to power our dev tools. So we could probably use Dino to run our linter or our prettier files or whatever you want, because it's still running TypeScript, so running JavaScript headless in the server in a browserless environment. So use it to everything that you want. You could use it if you want to run some kind of simple CLI. Here is a simple example. If I want to just make a cat-like function in Dino, I just import the copy util function from the util standard package, and I just open the file by taking the file name from the command line argument, open the file name, open the file, passing the content of the file through the copy function and outputting it to the Dino standout output, which is the console output, and just close the file. And this is a cat-like solution. Once again, I have to enable the runtime to read the content in my file system, because my file system is by default forbidden to be accessed to my runtime. So I could allow my runtime to read it and just cat the content, calling my file. So it's pretty much easier if you want to to create some CLIs or to create some handy solution. But you could also use it for advanced solution. In my previous example, I used the copy function from the util standard library, which means there is standard modules that are mimicked some node standard functions like the file system access and so on. They are a set of modules that are audited and maintained by the Dino team. They're available in a workspace, dedicated workspace named Dino STD for standard. And they're all accessible from the Dino land CDN at the dinoland/std namespace. So each time you need a function that is a standard function, a base function like file system function or promise function or something like that, everything is available from this library. It's a standard library that is a common set of common utils. Then you also have some kind of community modules that are advanced or different modules that you want to use in your project because it allows you to have advanced use of your Dino project, like, I don't know, QR code generation or whatever you want. All the modules are all served from CDN, and there is a curated list available at dinoland/x namespace, so you could load them from the Dinoland CDN. But because everything is loaded from CDN, every module, every dependency, it means that you can use another CDN if you want. And you have a lot of them available right now. You could use SkyPack, you could use GSPM, GSDeliver, ESMSH, NPKG, as long as your CDN is delivering an ECMAScript module for the modules that you want to use in your dependencies. Then you could use any kind of CDN that could serve your modules, which means you are free to really rely on the good CDN that is the best for your module and your application. Then, and it was also regrets from Ryan, Dino really overlapped with the brother. I mean by that Dino is using the same standard set of APIs that the brother is exposing, which means the brother is using ECMAScript modules, then Dino is using ECMAScript modules. The brother is using promise, then Dino is using promise. We have the same top-level objects, no more global instead of window. It's window in the brother, it's window on the Dino file too. We've got WASM support in the brother, we've got WASM support in Dino. And everything that is not standard, or that is not exposed by the brother too, is under private namespace for all the internal stuff, like Dino dot whatever you want. Because by doing so, you're allowed to write isomorphic code in TypeScript that is able to run in the brother and in Dino too, if you need it. So you could be free to extract your business logic in TypeScript itself and put it both in the client side and on the server side, which is really, really awesome. And then we have a lot of permissions that allow your runtime to enable some kind of access, like environment file, network access, read access, and so on. Everything is powered by a large community, which means that there is a lot of modules and a lot of frameworks available for Dino. So right now, you could really use it directly in production if you want, just because all the modules, the default modules that you may want to power your application or your solution are probably right now available on every CDN that is exposing the modules for the Dino environment, which is really cool. But as I said, I'm a web guy and I'm front-end web guy. So I wanted to see which kind of web framework would be available to run in Dino. So there is a lot of them already. If you're more an Express guy, you've got probably you probably want to have a look at Opin or Athens, Norlight, Aqua, Exxon. All these frameworks are more Express oriented and are compliant with the Express way to declare your web page in your application. If you're more coming from Koa, then you've got Oak or Echo or Dino train, and I promise this talk hasn't anything at all to do with this another framework. But yeah, if you want to do your own, we're running out of later permutation, so be quick to build your own if you want. But if you're coming from Koa, yeah, those solutions are really nice, and there are other ones more oriented in specific topics like Drush. That is really useful if you want to power an API solution like you could do with Laravel in PHP. I really love Drush. It's really, really powerful when you want to just to build an API under Dino. So I was with that saying, okay, I've got a lot of web frameworks available to run with Dino, but as a front-end person, I run components, and I'm working in a component-oriented era. So what about running React in Dino? Is it available? Is it just doable right now? Of course it is. We have a solution named Alpeh, which is the same thing that Next.js, how we said, or at least it's inspired by Next.js. And that is the same way and the same kind of solution, but running in Dino by itself. So let's have a look at it and how to run a powered web platform under Dino using Alpeh. First thing is, because we are using TS, TypeScript as a first-class citizen in Dino, then we could rely on TS6, like that is a GS6 in TypeScript, directly in our Dino application. So I import React directly from my CDN, so from ESMSH. I import my own components from my application, like a logo component, and I just export the default rendering function that is my home page, that is just returning a couple of components like a div that is wrapping my logo and a hello world thing, and that's all. And I've got a web page that is running under Dino and that is powered by Dino, which is nice. So Alpeh is a zero config solution. It's TypeScript in Dino directly. We are using ECMAScript modules because this is Dino. So we are running ECMAScript modules directly. We've got access to import maps. We've got HTML. We've got file system routing solution. We could generate a server-side rendered solution and a server-side static generation of our website if we want. We still have access to GSX. And there is a lot of plugin system available. So it's a very complete solution with a lot of things inside them. This is not just a bare framework, web framework to do things. It's really an advanced solution to do that. So let's have a look at it more in depth. About the routing, everything is done from the file system. So I've got access to a pages folder. In this pages folder, I could create as many pages as I want to handle all my different routes. So any new top component in my pages folder will be an ending route in my Alpeh solution, in my Alpeh application. So I still import React. I could import my nav application, and my nav could be a simple list of anchor tags. And those anchors are declaring an URL as an href. Because Alpeh is aware of that, he will properly handle the anchor tag and replace it with a proper routing function directly on them. So I don't have to declare my different routes at some point and so on. As long as I have a link that is pointing to a page that is referenced on my file system under my Alpeh project, then all those links will be converted to a route in my final application. So I don't have to worry about declaring my routes. Everything is handled directly by the framework, which is really, really impressive, because I just have to write some kind of components in GSX, so doing basically React on server, and it will just work out of the box. Nothing to have to do with that. There is a first-class CSS support directly in it, so I could import my CSS files directly in it. I could also import CSS files from CDN server, like importing the Tailwind CSS file don't do that at home, kids, because those guys are professional and you don't want to import a Tailwind full CSS in your final project. But you could do it if you want. And we've got access to a style module that is finally just a CSS in GS module directly into our React application powered by Alpeh. So I can just rely on those styles and declare those styles directly and use those styles directly in my components as a first-class citizen module. So this is really, really impressive too. Because I don't want to handle, let's say, the Tailwind CSS by itself, Alpeh isn't providing a solution to handle the Tailwind classes directly out of the box. But there is a really useful plugin API in Alpeh. So I could create or I could load plugins for Alpeh directly from my different CDN. In this example, I just load the config types from Alpeh from the Dino CDN directly. Then I import two kinds of Alpeh modules, a Markdown module that allow me to write Markdown in my GSX and having the Markdown converted to my final markup and my final components. And I could also import Windy CSS plugin for Alpeh. Windy CSS is a solution that is replacing Tailwind that allow you to directly generate at the runtime the different classes for the Tailwind style sheets that you are currently using. This is exactly the same thing that Tailwind is doing with its just-in-time compiler, but probably better handled in a dedicated plugin. So we could have a plugin that is developed for Alpeh directly and is available as a module on the Dino CDN. So I just load those modules, pass them to the Alpeh config file, and that's all. Everything will work out of the box. So what about server-side rendering and server-side generation? We don't want to probably build for performances reasons. We don't want to have our pages rebuilt each time we request them. So we are more and more moving to server-side rendering and static side generation, which is exactly what Alpeh allow you to do in your production environment. You just have to run Alpeh with a different series of SSL calls, and it will generate pages that are ready to be hydrated directly in your browser. So all your markup will be pre-rendered in your final pages. You save your final pages with a really small amount of JavaScript as a client in your browser to just hydrate those pages. And because you probably want to access during this server-side generation to some kind of content, Alpeh allow you to access different elements like request headers or different elements that are exposed during the request by itself. So during the dynamic part of your application rather than on the server-side rendering part. And those elements are exposed in your final pages, in your final component as properties. So you could use them as React properties as you may want to do in your final application, which means that I could write my client's application or my server application the same way, using the same patterns, using the same properties, with the same language or the same framework, using TypeScript and React, for example, which means I'm really working in an isomorphic environment from the client to the server, thanks to the browser and React from Dino to the server. But because I'm really looking to advance and standard technologies, I prefer to bet on web components for a better interoperability rather than focusing on React-specific stuff or something like that. What you see here is a screenshot of webcomponents.dev, which is a tool we are developing at DevRiots, my company. And this is an online editor for your web components. So because I'm using web components a lot, and I'm developing a lot of web components, I wanted to see if I would be able to embed my web components into my React application in Dino using Alpeh directly. Would it be possible or not? The response is yes, we could do it. And one of my preferred framework for web components is Stencil.js, and Stencil would be perfectly compatible with the Alpeh requirement. Here is a simple web component declaration with Stencil. So I just declare a new component, I name it and export it, declaring some properties and using those properties in the render function. This is a really simple web component, basic one. If I want to use it in my Alpeh application, I could embed it because I could just load it from a CDN export and having it available in my final React markup, because I could embed any web component in my React markup. This is no problem for that. But because my pages are rendered on the server side by Alpeh, do my web component compatible with this server-side rendering process or static site generation process? The first answer is no. Web components aren't compatible with SSR. Why? Because to be really compatible, the web components need to have access to the DOM API. And the DOM isn't available on the server side because you are running outside of the browser. So it's a game over. But we have some solutions that we could use. If you use Stencil to build our web component, we have an SSR flag that you could pass to the Stencil compiler, which means that each time I'm developing a web component, I compile it using the Stencil compiler with the SSR flag, so the pre-render CLE flag provided, and I will have a component, a JS JavaScript component, exposed in this hydrate module. So if I load this hydrate module directly, I could access to a rendering function. So I could use the plugin API in Alpeh directly. I will load the plugin API, the plugin types definition from the Dino CDN. I will load my hydrate from my previously compiled web component, and I will create a new plugin for Alpeh that is responsible on the rendering event on Alpeh to parse my HTML and to render the content to strings, so converting the web component directly into a rendered HTML directly in my final rendering process. So Alpeh is passing my React components and passing my pages with my web components embedded inside it, which could be the same code as that I would use from my client side. And at the rendering process, it will replace it using the SSR function provided by the Stencil web component one, which is cool. But what about if I don't use Stencil? Because I will probably use some web components that aren't developed by using Stencil. So we have another solution coming from the Skate.js web component framework that is a standalone solution. And this is an SSR-like runtime available as a standalone solution. So it can be used with any kind of web components. It's not a real static site generation because it will just render as much as HTML as it can and just adding a few lines of client-side JavaScript to hydrate the content in the browser. But it's better than nothing. So we could do the same things that we did before, creating a plugin for Alpeh, loading the SSR register function from the Skate.js project, and importing in directly and for all the plugin on the rendering process in Alpeh, just rendering the new content for all the web components and content in the page, and just pushing the script at the end of the page to allow the rendering process as the hydration process in the client side finally. So that's almost everything for me. Dino is really a bright future. It's here for 3 years right now. So we could say that it's robust enough to be used in production with a lot of modules available in the environment. So that's really, really nice. It's really great for server-side tool as well as web frameworks or web server tools. It's secured with TypeScript by default, which is really fun. Front-end performances needs a proper SSR, and we saw that we are able to embed real front-end performances things and a real rendering process directly on the server using some solution like Alpeh. Never trust people that say that web components can be rendered on the server because it's wrong, and we saw that. So yeah, we could render web components on the server. So bet on web components as we bet on JavaScript, and use them as much as you can to develop your different modules and your different components that you want to share into different kind of projects. And the next step is probably something like running Dino in the browser. So when I'm saying that, people often say, wait, just Dino is TypeScript and TypeScript is JavaScript and JavaScript is already running in the browser. So what do you mean by running Dino in the browser exactly? So yeah, I mean, we don't want to still use imports from the Node modules and having to rely on npm, and we need something that is really advanced to do so. So maybe we could be inspired by the work of the Dino team in the browser directly. In the company I'm working on in Dive Riots, we are working on different kind of projects, and we are working on a project dedicated to design systems. And in design systems, we are using a tool that is named Style Dictionary. Style Dictionary is a pretty much powerful tool that is made by Amazon and that allow you to declare different design tokens and convert them. But unfortunately, Style Dictionary is only working on Node.js because it heavily relies on the file system. So we forked Style Dictionary and we put it in the browser exclusively. And all the tools that we're making in Div Riots are working all in the browser with no server side at all, except for serving the assets, which means that every tools that are running in the Node.js environment are ported in web workers to work in the web workers in the browser itself. And we are really deeply inspired by what the Dino team is doing by importing modules from CDNs, by running them with a compatibility layer with the browser, because this is exactly the future that we want. Having the possibility to run the same code on the server side and on the client side using the same languages, the same kind of frameworks, and expecting the same performances and the same capabilities. So thank you very much. I'm Mads. I'm principal developer advocate at Div Riots. We're working on a lot of tools like Backlight, as I said, for design system. Have a look at them if you want. And if you have any question, I'm here. We still have time, which is really nice. So so feel free to ask. I see there is a few questions in the chat, so let's talk about it. Thank you.
Yeah, thank you, Matt, for this. Was a really great talk, and I like a lot of parts about Dino because throughout these 3 years, I was only hearing some stuff that Dino's this and Dino's that, but not actually how the ecosystem developed throughout this time. We do have one question from the audience, but I'm not sure I quite catch what is the case. I'm gonna try to so the question was from Olga: Dino and React Native app in offline mode, is it possible?
That's a good question. React Native app in offline mode mean that you want to have all the dependencies that you need directly loaded in your application and available in your headless, Chromeless browser when you run your native React Native app. So I'm not really sure about the sense the question by itself, but the fact is, if we're speaking about dependencies and modules, I had the question before about, okay, we're loading all the dependencies from a CDN and not from local dependencies. So what about if the CDN isn't available because I have a network issue or because the CDN is just down, which happen? And the answer is Dino is loading the dependencies and cache them locally at the first run. And if you don't pass it a reload flag when you run the Dino runtime, then those dependencies are used from the cache by itself rather than from the CDN directly. So you need a network access to load the dependencies at first, but after that, all the dependencies are available in the cache locally. So in the case of a mobile app where you don't have any internet, that would be served by Dino. Every kind of modules would be loaded in your Dino application at the first time. Then your Dino server don't need to access any CDN access CDN dependencies, and everything will be then cached and embed in your final React Native app or client app, whatever technology it is, and will be served directly. So yeah, I guess there is no problem thanks to the different caching strategies from Dino, from the brother. All those caches allow you to have a seamless integration of your different dependencies.
Yeah, I'm gonna add that I don't think you still need like a build step and pack step to produce a mobile application, whether it's a React Native application or a native mobile application. So you still need to get your dependencies bundled somewhere, and I don't think you can't run to Dino on the mobile as a mobile application, as I understand. So yeah.
Yeah, definitely. But you could use you could obviously use Dino as your backend for your mobile application, which could be a really great use case using Alpeh or using Drush or whatever web framework solution you want in Dino.
Yeah. Also, when you are talking about that, someone may remove the code from the GitHub, so you need to cache it first, and maybe you need to provide some proxy service. So if you think that depending on npm.js registry is good enough, I'm going to let you down, because right now I'm looking at the npm status page, and npm.js website and package installation has a major outage, not as far as like 7th of October. So if you don't have a local proxy on 7th of October, you may experience some problem on the CDN because the registry was down.
Yeah. This was just the problem with the npm solution, I guess, and I guess this is exactly what Ryan is saying in his talk. It's that it became a de facto standard, but now it's a bottleneck, and each time you need to access a new dependencies because you need to install it and you need to rely on it, you will probably face some kind of issues because the npm registry could have any outage or something like that, or so the idea of relying on CDNs to distribute the package in a mesh rather than in a central point, because you could switch to any other CDN if you want, because you don't want to use Skypack or Skypack isn't available anymore, then you should just move to the SMSH and it will just work out of the box, because this is the same thing, just another solution, another framework, another CDN available to run your different dependencies. So yeah, it's brilliant.
Yeah, and also let's not forget about that most of the npm packages requires a build step. So you have the possibility to install them from GitHub, but in reality, you can't install most of the packages from the GitHub because you don't have, the actual compiled sources. And when you do this, like Dino does, you can just commit and install as you do with npm.js like git and then just commit hash.
Yeah, exactly. So it's probably another way of thinking, I guess so. But what we are trying to do at DevReax with our editors is that because we don't want to rely too much on the registries, we load the different dependencies and packages from different kinds of CDNs, NPKG or ESMSH or whatever you want. And we use a tool called packd, which finally called the CDN for us and pack everything that we want in a single GS bundle dependency that is served to our final application, which is really useful because we just have to declare in our code, okay, I just want to use import this module and this module and this one, and in the back, packd will do the work for us by catching and gathering all the dependencies that we need, saving it in just one file, and it's perfectly transparent from our front end point of view. So this is probably the future of handling and managing the dependencies, and this is directly coming from the Dino experiment.
Yeah, all right. I think it's time to move to our discussion zone. So please join in. There is a Zoom link in the chat. So thank you for guys and girls and all the folks for listening. Goodbye.
Goodbye. Thank you very much for being here. Bye.